Calculus, hello, welcome to your Monday, October 25th notes. All right, I'm gone from you just one more week, hopefully. Hoping to see you guys as the month turns to November 1st, next Monday. All right, so we are in section 2.7, day 3. We're actually going to start 2.8 later in this video. So here are a few more interesting examples as someone that has looked over homework set number 3 and then also homework set number 4 here coming to you soon. Relatively easy homework sets to end this chapter if you ask me. Find the equation of the tangent line to the curve at the given points. All right, so we have f of x is equal to the square roots of 2x minus 7 at the points. Plug 4 in for x, and you get the square root of 1, which is 1. Again, you have to know this. Got to have this one down. Again, it's just a slope formula. Find what the equation of the tangent line. Tangent line is a straight line that intersects the curve at exactly that point. It kind of bounces off. Slope of any line is difference of the y's over difference of the x's. Okay, so that's one we have to have memorized, and we'll get the next one down. There's two we got to have down for this chapter, and it's this one here, and it's sort of like the f prime of a, but it's like another one that's coming up later. So add the limit, or the slope is equal to the limit as x approaches 4. It's approaching 4 of f of x minus f of 4, f of a, which is 1, all over x minus a, 4. I need to multiply the top and the bottom by the conjugates of what I see in the numerator. And when I multiply by conjugates, 2x minus 7 falls out. A negative 1 times a positive 1 is a negative 1. I need to combine like terms. All right, so nothing cancels right away, but if I factor out a 2 in the numerator, here's what I got. I see that the x minus 4 is, again, if x is going to 4, this is what's problematic, the x minus 4. This is what has to cancel. All right, and pause this if you need to. If you need to write all this down, that's fine. I'm about to cancel the x minus 4s. And we have the limit as x goes to 4 of 2 over that square root plus 1. I'm going to plug 4 in for x. I get the square root of 1, which is 1. 1 plus 1 is 2. Again, when I plug 4 in for x, I don't have to have the limit. I don't have to have the limit as x goes to 4 anymore. And there is my equation. Again, we write it in point slope form, which is a y minus the y value is equal to the slope times x minus the x value. We talked about this in college algebra. That point slope form was a coming, and now it has its moment. It's point slope form time. All right, point slope form gets to throw the passes now. Let's take a look here at number 2. Well, we might have done a few like this. I just want to tie it up here so we can handle any sort of question we might see on our homework or any quiz exam reviews. F of x is equal to 7 minus 3x squared. I want the equation of the tangent line to that curve at that point. The slope is equal to the limit as x goes to 2 of f of x minus f of a all over x minus 2. I'm going to write that as a quadratic in its proper form. I'm going to factor out the negative. That changes all the signs. Again, if our factoring is not great, you know that x minus 2 has to be factored. So x minus 2, and that gives me a 3 times x is 3x squared. A negative 1 times a negative 2 is a positive 2. Check it if you need to. Negative x minus 6x is a negative 7x. What's going to cancel? The x minus 2's. Be careful, you still have that negative sign. So I'm left with the limit as x goes to 2 of the opposite of 3x minus 1. So I plug 2 in for x. My slope is a negative 5. And you can also look at this graphically. Go to Desmos, use a graphing. If you have a graphing calculator, use that. This is a upside down parabola, the igloo. And it's going to be going down at 2, 2. So slope of the tangent line has to be negative. It's decreasing, so the derivative has to be negative. Okay, and we keep talking about derivatives with the slope of the tangent line. Slope's a rate of change, a derivative is a rate of change. There's a way to just get the general derivative. So, all along its curve, I know exactly its rate of change. It's instantaneous rate of change at any point. I don't have to do this for all the infinite points that this curve could go through. And we are getting there. All right, let's take a look here at number 3. I thought this was a good one. We got 4 over 3x. So f of x is equal to 4 over 3x at x equals 6. So I have the limit as x goes to 6 of f of x minus, oh no, I didn't give you an ordered pair. I don't know what f of a is. So I plug 6 in for x. That's 2/9. Always simplify it. That's why I have 2/9 there. So off to the side, 4 over 3x minus 2/9. You might have seen this in chapter 8 of college algebra a bunch. I'm just going to get this fraction x over s. X over x, I'm going to give this a 3 over 3. So I have a 12 minus 2x. Okay, so yeah, this here, that numerator is going to be 12 minus 2x over 9x. 9x is the common denominator. All right, so here's what I got. Factor this out. There's a 2 those two terms have in common. So 2 times 6 minus x. Now it's important to know that the 2 times 6 minus x and the x minus 6 are in the exact same location. They are the numerators of their respective either true numerator or true denominator. And they will cancel, but they'll cancel to be a -1. 6 minus x and x minus 6 are opposites. All right, so you're going to have a -2 over 9x. The limit as x goes to 6 of that function. And you're going to plug 6 in for x, and you get an interesting slope. -1 over 27. Okay. Y minus the y value is equal to the slope times x minus the x value. You can always pause this when you need to. All right. Then let's bring up something we need to remember from college algebra. This might happen from time to time. So you've got this polynomial. It's raised to the 3rd power. We learned in algebra 2 what the end behavior is going to be like. This is an odd function, leading coefficient, so it means it ends by going up because it's odd. It's in behavior in the opposite direction, something like that. All right. So we have the limits as x goes to -1 of f of x minus f of a. You're subtracting negative. Make sure you have minus in parentheses a negative all over x minus a. A lot of subtracting of negatives. All right, so we're left with that. I got no idea how this is going to factor. I'm not going to factor it by grouping. That's not going to work. So instead, I know x plus 1 has to be a factor. So I set x plus 1 equal to 0. I know -1 has to be a solution. So I use synthetic division. I put -1 in the cubby because I set what I'm dividing by equal to 0. Is x plus 1 a factor, or is x equal -1 a solution? 4 for 4x to the third, -5 for -5x squared, 7 for 7x, 16 for the constants. 4x to the third, I bring the 4 down because I'm doing 4 divided by 1. 4 divided by 1 is 4. That's why I bring this down. -1 times 4 is a -4. Add them up. -1 times -9 is 9. Add them up. -1 times 16 is -16. Add them up. They're opposites. 0. That's good. It means x plus 1 is a factor. So synthetic division shows that you have divided. Okay, it's like showing something like this. Okay, synthetic division or long division you might see in a book as well. Someone remind me to show you how to do this long division. Using long division, because if you're dividing by like x squared or x to the third, you want to use long division. So make sure we'll have time when I come back on Monday the 1st. Somebody asked me about long division. Brownie point whoever asked first. All right. So what does the 4 mean? You had 4x to the third divided by x. X to the third divided by x is x squared. So that's a 4x squared minus 9x plus 16. And again, you have divided by x plus 1. That's what synthetic division does. It divides away the x plus 1. X is going to -1. I plug -1 in for x. get a slope of 29. Very, very small slope in 3 followed by a large slope in 4. Y minus y value is equal to the slope times x minus the x value. Okay, so what do we got there? I think then we are in fantastic shape to look at top of 140, bottom of 145 and top of 146. I think we're in awesome shape to finish the homework sets number 3 for chapter 2. That's about everything there. If there are any other, no, I think that's about it. That is about it. So I think we're in good shape to handle that homework set. I think you have 12. You got 12 questions right. Just find the equation of the tangent line through to the curve blank through a different point. You guys can handle that. Start on it early, please. Early and often, folks. Early and often with that math homework. That first part, count it as a rough draft. Write it on a separate sheet of paper. Make sure it's absolutely perfect with a ton of work shown. That's how you would handle all of your math homework for the rest of your math career. All right, let's talk about rates of change. So take a look at this curve right here and what's going on. So this right here, look at that. What do we got? We got a tangent line. All right. So suppose y is a quantity that depends on another quantity x. Thus y is a function of x, and we write y equals f of x. If x changes from x1 to x2, that's what's happening, x1 to x2, you have a change of x, while you also have a change of y. Then the change in x, also called the increment of x, is that. That's the change of x. And the corresponding change of y is that. Difference of the x's, difference of the y's. Remember, f of x is a y. The difference quotients, look at this difference quotient. All right, is called the average rate of y with respect to x over that interval. Okay, now, by analogy with velocity, we consider the average rate of change over smaller and smaller intervals by letting x2 approach x1, and therefore letting the change of x, delta x, or h, before approach 0. The limit of these average rates of change is called the instantaneous rate of change of y with respect to x at x1. All right. Which, as is in the case of velocity, is interpreted as the slope of the tangent line to the curve right there. So instantaneous rate of change is the limit as x approaches 0, delta y over delta x, which is the limit as x2 approaches x1 of f of x2 minus f of x1 over x2 minus x1. We recognize this limit as being the derivative f, that looks like an apostrophe, it's called f prime of x1, f prime of x1. And we're going to talk about that more later. All right, and let's write that right here. Write this down. The derivative f prime of a is the instantaneous rate of change of y equals f of x with respect to x when x equals a. And I think you can write that down there, but I want to mention something. So pause that if you need to. I'm going to switch over to my page. And I got a few things. So I have exactly what was just written. But I want you to go right here. So with respect to, in college, if a professor writes WRT, that means with respect to. WRT, if you're writing and you're like, what in the world does that mean? They're like, change of y equals x, WRT, x, that means with respect to. Also, if you see if with another f, you're like, oh man, my professor might be illiterate. No, that means if and only if. So that actually happens a lot, and we'll see when it pops up for us, but you're going to write that a lot if you take more math classes. That means if and only if. So WRT means with respect to, and then that is if and only if. Instead of writing, 1, 2, 3, 4 words, you can write 3 letters. Instead of writing 1, 2, 3 words, you can write 3 letters. Okay, so just know that's just an abbreviation, use the time. All right, so we are going to find one of these derivatives, and then we're going to go to section 2.8. So this is the last one of section 2.7. Find f prime of a if f of x is 1 minus 2x in the square root of 1 minus 2x. So from before, now you don't necessarily have to have this one memorized. We're going to have the general limit definition of a derivative very, very soon, in a few minutes. So f prime of a is the limit as h approaches 0 of f of a plus h minus f of a over h. So the f of a part minus f of a, that's pretty easy. Just plug a in for x, divide by h, and you need to plug a plus h in whenever you see x. So 1 minus 2 times a plus h. And I simplify that, and that's what it is right here. That's the whole f of a plus h minus f of a over h. Now, I need to get rid of that, right? So I need to multiply by the conjugates of the numerator, which are the same 2 roots with a plus in between. So when I multiply by conjugates, root times its root, that falls out, 1 minus 2a minus 2h. Minus the entire quantity of 1 minus 2a, minus the entire quantity of 1 minus 2a. So you're actually going to be adding 2a. And you guys know that. Anything without an h is going to need to cancel. All right, so the 1's cancel and the negative 2a's cancel, leaving you with a negative 2h. Negative 2h up top. Again, right. That's that left side here. Pause that if you need. I'm going to move over here. Okay, what's going to cancel? This h over h will go bye-bye. I'm going to cancel that in 4 seconds here. All right, then I have a negative 2 all over that conjugate. Now I can let h be 0. So I'm going to let h be 0. That means this is no longer there. Now I have 2 of the same roots, so that's why I wrote 2 times the square root of 1 minus 2a, and the negative 2 over 2 cancels. Negative 2 over 2 cancels. That is my derivative at just any a. If I want to know, hey, what's the rate of change of this function when x is 4 or a is 4? Plug it in there. What's the rate of change of this function? Oh, it can't be 4 because it can't be 4. Scratch that. Edit that out, because if you plug 4 into the initial, plug it in there, it's undefined. So how about when it's negative 4? How about when x is 0? How about when a is a negative 6? You'll know. So that seems like it's a little more important than trying all those, find the equation of the tangent line. It feels like if I can get that general derivative, I'm in much better shape, and that is where we're at. We are going to do one question in section 2.8. Here it is, section 2.8, the derivative as a function. So we have to do, and this is a standard question on many Calculus 1 final exams, find the derivative of this function using the limit definition, no points given for using simple derivative rules. Okay, so this is one that will be on your fall final and the big one in the spring. All right, so f prime of x, that is the derivative of x. All right, write that down. F prime of x, little apostrophe there. F prime of x, that's the derivative of x. And f prime of x is equal to the limit as h goes to 0. H is a horizontal distance. Think of it as like the x1 minus x2 that we just saw, of f of x plus h minus f of x. All right, so you're thinking like, well, these are different functions. Well, if h is becoming essentially 0, then you're basically just looking in at that exact function at a certain x value. All right, remember that horizontal distance, that h is approaching 0. So you need to remember this. You need to star that. We need to start putting that in our noggin whenever that next quiz is, looking to skyward. You're going to have this down. All right, so that is something you got to have down. The limit as x approaches 0 of f of x plus h minus f of x over h. So find f prime of x if f of x is equal to 3x squared minus 7x. Here it is, folks. You are finding the derivative of that function. All right, so f prime of x. Now, we only have one section where we have to use the limit definition of a derivative. Chapter 3, we find out, and some of you at the end of the section are just going to know the rule. And if you know, you can kind of see what's going on. You can be able to check your answer on your next exam. We only have one section where you have to do the limit definition, and one homework set where you have to do that, and then it's all derivative rules. All right, so we have the limit as h goes to 0 of 3 times x plus h squared minus 7 times x plus h minus f of x. Now you're subtracting all of f of x, folks. Every year I see just a minus in that. And students, instead of subtracting a negative 7x or adding 7x, because it has to cancel with this negative 7x, instead have a negative 14x that's left over. It doesn't cancel with h. All right, so x plus h squared is this, minus 7x minus 7h minus 3x squared. To subtract a negative is plus 7x. Those will cancel. I didn't cancel them out right away. I just wrote everything down here. That's going to be... And a lot of books, like if you're reading this in a calculus book, like it'll have this first step and then it'll jump straight from here. It's going to assume that you know the algebra that has to take place, okay? Then we cancel out like terms, a boom and a boom, and a there and a there. Anything that's left over only has h's. Now I divide everything by h, and I let h be 0. The derivative of 3x squared minus 7x is 6x minus 7. What does this mean? This means if I want to know what is the equation of the tangent line when x is 2, just plug 2 into this derivative. What's the equation of the tangent line when x is a negative 4? Just plug negative 4 in here. If I want to know what's the instantaneous rate of change of this function when x is 0, plug 0 in here. You guys can see how nice that makes this analysis. All right, if I've got a certain curve, if something goes in motion, defined by a certain function, I can always know its instantaneous rate of change by a simple first derivative. That is really big news. All right, so folks, thank you, and thank you. I know you're watching this on Monday the 25th. All right, I'm getting a lot of videos out early for next week, so I will be checking those view counts, folks. I will be checking those view counts. I've got a lot of time to add questions to quizzes and exams and make new homework sets. So please, ball's in your court, folks. Let's be smart about this. Watch this video. Looking forward to seeing you in a week. This is Yak Math Videos, signing out.